Good afternoon, everyone. Thank you for joining Hosokawa's webinar on Grit to Gold, Improving Carbon Black Value. My name is Greg Boyer, and I'm the Marketing Manager at Hosokawa Micron Powder Systems. We hope you find today's presentation informative and enjoyable. If you have any questions, please feel free to submit them using the question panel on the right side of your screen. We'll answer as many questions as possible at the end of the presentation. At this time, I'd like to introduce today's presenter, Bill Brown, the Director of Sales and Marketing at Hosokawa Micron Powder Systems.
Thank you, Greg. Let me begin by outlining the topics that will be covered in this presentation. We'll begin by reviewing the current market conditions. The goal for manufacturers is to produce the best quality with the lowest grit, the quality of which is performed by a water wash residue test. The amount of grit is measured on a 325 mesh sieve screen and determined on a parts per million basis. I will cover two technologies that manufacture near zero grit products, the Micro EACM2 and the Micron Separator. I will first discuss our latest advancements for grit reduction, or micronization of coarse grit particles, called the Micro EACM2 Air Classifying Mill. This mill is specifically designed for carbon black grit reduction to ppm levels below 1. I will show operational data comparing the product quality from the standard EACM to this new development. For those clients who wish to remove these grit particles instead of grinding them down, our Micron Separator Air Classifier is the machine of choice. I will review operational data and sizes accordingly. I will then close with a comparison of grit reduction versus grit removal advantages and disadvantages, followed by a question and answer form. With fluctuating feedstock oil prices, perhaps one objective for a carbon black manufacturer would be to minimize the exposure of feedstock prices on these manufacturing costs. While some feedstock oils may be procured at a lower cost, the quality is much worse and produces a much higher carbon black grit content using conventional hammer and screen mills, also known as pulverizers. Additionally, environmental regulations and government crackdowns are being imposed, not only here in the US, but also in Europe, and most recently now in China. The type and quality of oil feedstock affects the process, and also how much pollution may be created for these processes as well. All these factors should be considered in selecting an optimal grit reduction solution. For commodity black products, perhaps the primary objective would be to source a lower quality feedstock oil, minimizing these manufacturing costs while simultaneously reducing the grit level of the product to the current standard while using the Micro EACM2. Or, alternatively, one may consider targeting specialty grade markets, using better quality feedstock oil and using either the EACM2 for grit reduction or the Micron Separator for grit removal to achieve near zero grit levels. For the former case, product quality can be maintained while reducing manufacturing costs. For the latter case, however, manufacturing costs can be maintained while manufacturing a higher quality product at a much higher profit margin. So I will discuss two different technologies designed by the Hosokawa Group to manufacture a superior quality near zero grit carbon black. The first, on the left, is the Micro EACM2 for grit reduction, or grinding down these particles. The second I will focus on is the Micron Separator Air Classifier, which removes the grit particles from the carbon black fraction. Now, let me go over a brief history of Hosokawa's grit reduction technology. Hosokawa is the inventor of the micropulverizer hammer and screen mill, used by carbon black manufacturers for decades now to reduce grit levels down to about 100 to 150 ppm, plus 325 mesh. Hosokawa also launched the LGM vertical long gap mill about 15 years ago for optimum grit reduction. However, we observed a few things. First, the complex rotor and classifier design attributed to a very high differential pressure, requiring a large material handling fan and consuming a large amount of power, thus a very high operating costs. Second, by design, this complex rotor and classifier is quite costly not only from a upfront capital cost, but from a maintenance and parts replacement cost. Additionally, this complex rotor design does make it challenging for maintenance teams because as you can see, the hammer assembly is quite extensive with many rows and many types of many hammers with tight clearances. About 10 years ago, we developed a micro EACM, air classifying mill, to bridge the gap between the LGM vertical long gap mill and the incumbent pulverizer. Now, since then, many EACM mills have been sold for this application with success, with grit levels down below 10 ppm being possible using this standard EACM, even for coarser grit feedstocks. So with our latest advancement, we do indeed bridge the gap and also replace the high cost of this long gap mill technology. The Micro EACM2 is capable of producing a product quality at less than several ppm using even a poor feedstock oil and near 0 ppm using a better quality feedstock oil. The EACM2 has a lower capital cost, lower operating cost, and lower maintenance cost compared to the LGM long gap mill, while producing the same, if not better, quality carbon black. Here's an image of a pair of Micro EACM2 size 200 air classifying mills. Here we have the common feed and air inlet. Up here, this square flange here is the product outlet. So the pulverized or grit-free product is then conveyed from the outlet of this EACM to a downstream bag filter. Now let me explain how the EACM2 works. Inside we have a size reduction or grit reduction zone here, and the upper portion is the classification zone. Now with the grit reduction or size reduction zone, there are two primary stressing mechanisms here. It's primarily or 80% mechanical impact. That's the hammer plates beating or reducing the size of the particles, and about 20% particle-to-particle attrition or collisions. The particles colliding off each other in the grinding zone here. And with this hammer rotor assembly, we're achieving tip speeds of about 110 to 120 meters per second. When the particles are ground, they're presented to the classifier wheel, which not only controls the cut point or top size, but also controls the residence time in the mill. So if the particles are too coarse, they're exited out of the mill through this eductor assembly. They evacuate the mill and are redirected into the inlet, the primary feed inlet of the mill here. Once the particles are reduced enough, or they're fine enough, they're removed through the classifier wheel and collected downstream into the primary bag filter. We redesigned the size reduction and classification zones of this mill. So while principally the unit works similarly to that of the standard EACM, it is now capable of reducing the grit levels to below 1 ppm, near 0 grit, for numerous grades of carbon black. The EACM2 can be retrofitted in line into your existing process, either taking the place of the pulverizer or perhaps bypassing the pulverizer to produce those finer grades of carbon black. The mill can handle process streams in upwards of about 200 degrees C. And one final note is that the largest mill we've manufactured to date, the EACM 300, can produce grades up to about 12 tons per hour. Now let's take a look at some comparison data between the incumbent technologies and the newly designed EACM2. The first comparison I want to show here is a 7.7 series grade of carbon black, which has a feed grit level of 600 ppm plus 325 mesh. Now what we're doing here is we're comparing the standard EACM to our newly developed EACM2. As you can see, with the same feed grit level, with the standard EACM, we're able to achieve less than 32 ppm plus 325 mesh. However, with that same feedstock, we're able to achieve less than 1 ppm plus 325 mesh with the EACM2. Now let's take a look at another comparison. Here, we're comparing an N6 series grade of carbon black, comparing three of our milling technologies: our standard EACM, our LGM vertical long gap mill, and our new EACM2, all at the same feed grit level of about 600 ppm. So with the EACM standard, we're able to achieve 51 or less than 51 ppm plus 325 mesh. Now, as I said before, the LGM was quite a bit better at less than 17 ppm plus 325 mesh. But now comparing that to the new EACM2, we were able to achieve less than 6 ppm plus 325 mesh, quite a bit better than the LGM long at mill technology. One final type of comparison I'd like to show you here is for an N300 series grade of carbon black with two different feedstocks, two different quality of feedstocks. One with a feedstock at a grid level of 1000 ppm plus 325 mesh, and one at 3000 ppm plus 325 mesh, where the new EACM2 is able to achieve less than 12 ppm plus 325 mesh at a starting point of 1000, and less than only 18 ppm with a starting point of 3000 ppm plus 325 mesh. Here's a general chart outlining the sizes of the EACM and EACM2 mills, from our pilot size EACM10 to our largest to date EACM 300, capable of processing nearly 12 tons per hour. What I'm also showing here is just some nominal data, some nominal airflows for the different size mills, scale-up factors, and just some overall dimensions, weights and dimensions of the different mills. Here is our EACM size 10 pilot size, and this is one of our larger EACM 250s. As I mentioned earlier, the EACM technology can be installed either offline with its own filter and pneumatics, or retrofitted inline. The offline process is similar to our setup in our test center using our pilot size EACM 10. For retrofitting inline, the existing pulverizer would either be replaced or bypassed using the existing downstream bag filter and adding a material handling fan. Here's a schematic of a typical EACM or EACM2 for grit reduction. Now, for simplicity's sake, I'm showing only two upstream filters from the reactor, but there could be quite a bit more. But the whole idea is we're taking the carbon black from the reactor from this bank of filters and showing that the feed grit or feed carbon black is conveyed with a positive blower into the EACM. The grit reduction occurs in the EACM or EACM2, and the product is then conveyed to the downstream existing bag filter. In this case, since we have a higher differential pressure or pressure drop on the EACM or EACM2 compared to the pulverizer, we do need to add a material handling fan to compensate for that static pressure. And hence the clean product is then collected downstream of the bag filter. For retrofitting the mill inline, as I mentioned earlier, since the pressure drop in air volume required for the EACM technology is quite a bit higher than the pulverizer, the retrofit will require that additional material handling fan or blower to compensate for that static pressure. And the pressure drop would vary on the type of carbon black, the capacity, temperature, and other process conditions. The EACM series can be designed to meet local ATEX or other explosion protection guidelines. As such, the mill can be designed in PSR pressure shock resistant construction if so required. For abrasive applications, high-speed internal components can be made in special wear-resistant materials. For those stickier grades of carbon black, we have successfully utilized low coefficient of friction coatings to avoid or minimize material buildup. This image here is a classifier wheel constructed with a special wear-resistant coating which increases the life of the part compared to standard stainless steel by a factor of about 3 to 4 times. So we basically coat the vanes of the classifier in order to increase the wear life. And to put it into perspective, this is one of our larger EACM classifier wheels. This would be for an EACM size 250. So what we're showing here, this gold color, is that special wear-resistant coating for those more abrasive grades of carbon black, but you can see it in perspective to the inspector here how large this is. And this classifier wheel here will be equipped with that size 250, which will do about 5 to 7 tons per hour. Now I want to shift the presentation or focus of the presentation to another Hosokawa technology. This will be grit removal or separation. Now, there may be cases in which removing the grit particles is the only solution. Perhaps these grit particles are refractory contaminants that adversely affect performance of the rubber molded product. Simply grinding them down won't work. So the contaminants, the contaminants are still present and would have to be removed. The Micron Separator Air Classifier can be utilized for this purpose. That is, to remove the grit fraction or these contaminants to produce a nearly zero grit material. Here's how the Micron Separator Air Classifier works. The feed material and conveying gas are pneumatically conveyed from the bottom of the Micron Separator Air Classifier and are presented to an internal dynamic classifier. So this classifier wheel is spinning at a certain speed specified by us and controlling your cut point or resonance time. The coarse particles, your grit particles, with some carbon black in it, would be rejected, dropped by gravity in this coarse fraction and collected into a tank of some sort. The fine particles, your carbon black grit-free particles without the contaminants, would pass through this classifier and get collected pneumatically downstream to a bag filter. Here is one example of a process utilizing the Micron Separator Air Classifier for grit removal. Now, the coarse fraction could be taken away and collected, or an ACM perhaps, or EACM2 could be added to reduce the grit level of that coarse fraction. So let me show you a few different products that could be achieved here. The first would be a clean, grit-free, and also contaminant-free grade for the specialty black rubber applications. Using the Micron Separator Air Classifier, number 3 here, and collecting the fines fraction here into this middle bag filter. So this is your contaminant-free, near zero grit-free product. There's also a case where you could take the coarse fraction, which also has the contaminants in it, and collect a product here in C. Now this would be for a more standard higher grit carbon black for perhaps a general rubber tire application. So this is your coarse fraction from the Micron Separator. Perhaps a third fraction would be a high quality near grit-free product, which is done via grit reduction or size reduction on the EACM or EACM2, where we're reducing those contaminants here. Now perhaps you could use this for other specialty grade rubber applications. So in effect what happens is that coarse fraction gets conveyed, instead of perhaps being collected in C here into this tank, would then be conveyed into the EACM or EACM2 for grit reduction, the product of which would be collected into the bag filter here on the right. So a process like this is just one example, but gives the manufacturer quite a bit of flexibility to produce a diverse range of qualities for various end uses. The Micron Separator series ranges from our pilot size, MS1, and upwards of our largest size, the MS6. Now for carbon black applications, we offer the size MS5 and the size MS6. The size MS5 for most products, we're able to achieve an input rate of about 1 to 1.25 tons per hour. For the MS size 6, for most applications for carbon black, we're able to achieve input rates of about 2 to 2.5 tons per hour. Now, let's compare grit reduction versus grit removal, and let's review the advantages and disadvantages of each technology. Using the micro EACM2 for grit reduction, for sure the advantages compared to the Air Classifier would be lower capital cost, smaller equipment, less money for sure. Smaller equipment obviously being a smaller footprint, so taking up much less space. Smaller fan, less airflow, lower energy costs, much less consumed energy. Additionally, lower maintenance costs. However, one disadvantage perhaps for grit reduction using the EACM2 would be the fact that even though you're successfully reducing the grit particles to near zero, those particles are considered a contamination perhaps, and those particles still reside in the carbon black product. For removal of grit particles from the carbon black product using the Micron separator, the main advantage, of course, would be the fact that you're removing these grit particles or contaminant from that carbon black product. However, the disadvantages then become higher capital cost, larger equipment taking up much more space, higher energy costs, and also higher maintenance costs. Let me show you a couple of photos here. This mill here is our pilot-sized EACM10. This is also our test mill, and we use this mill for all confirmation trials. So we offer to test your product in our test center here in Summit, New Jersey, or our test center in Japan to confirm particle size and mill capacity for scale-up. We're showing here a couple of EACM size 30. This is the next size up in the range. This mill is capable of capacities in about 500 kg to 800 kg per hour. And you can just see a couple things here. Here's the feed and primary gas inlet. Here's the product near grit-free outlet here. And here's the external recirculation here. The next size up would be the EACM 100, shown here, with capacities ranging of about 1.5 to 2 tons per hour. It does vary from grade to grade, but that's about the average, showing the 100 horsepower main grinder motor here, and the height of which, to give you a perspective, is about 2 to 2.5 meters tall. Next size up will be the EACM 150, slightly bigger than that size 100, with capacities in the range of about 2.5 to 3 tons per hour. One up from that would be the EACM 250, quite a bit bigger. The capacities here would range from about 5 to around 7 tons per hour on average. Now this one is an assembly, so we're not showing the main grit reduction motor, but you can see the classifier motor here, and this mill here is about 3 meters tall. This is the largest mill we've built to date, a size EACM 300. That's me in the photograph here, and this is just the grinding chamber as compared, so it's just basically this zone here that I'm showing you. So it kind of puts into perspective how much larger of magnitude this is. And this will do about 12 tons per hour. This is the air inlet here, and this flange here will then connect to the volute or the classification zone. In conclusion, Hosokawa can offer these options to meet your needs. Near zero grit product quality for special black applications are possible. The EACM2 air classifying mill outperforms other existing milling technologies. Lower grit levels to near zero are quite possible. The Micron Separator air classifier is an excellent alternative in applications that require removal of those grit contaminant particles. Each technology can be retrofitted in line to your existing process. The capacity ranges for the EACM2 are about 0.1 ton per hour and upwards of about 12 tons per hour, and the capacity ranges for the 2 Micron separators range from about 1 to about 2.5 tons per hour. Thank you very much for your time and attention. We will now open up for questions.
Thank you, Bill. All right, we're going to take some questions now that were submitted through throughout the presentation, and we invite you to continue submitting your questions, and we'll answer as many as possible. Bill, we're going to start off with some questions that were actually submitted before the webinar started by one of our customers. The first one was, what are the chemical characteristics of a good carbon black?
Chemical characteristics of a good quality carbon black. Well, you know, we are equipment manufacturers and not the chemists working for the carbon black manufacturers, but I would say defer to them, but I would say a couple of things. First, obviously, particle size is an important characteristic, which is what we're focusing on with the grit reduction and grit removal. But also other things that I've learned, like structure or porosity or surface chemistry, all would be considered very important characteristics of a good quality carbon black.
Okay, next question. How can you change the grade of carbon black when you have a virgin carbon black that you want to get down to the 330 or N55 class? Is it only with the mesh size?
How can you change the grade of carbon black? Well, I mean, I'm not sure if you can really change the grade of carbon black. I think the grade is the grade for the most part, and I would defer that again to a chemist at a carbon black manufacturer. But with respect to changing, what we can change the grit level or particle size distribution, or the aggregate particle size distribution using the EACM or EACM2.
Okay. All right, next question. What is the internal material of construction? I'm assuming you're talking about the machines, the EACM or the classifier.
I mean, for the most part, we're dealing with stainless steel. Most commonly, the requirement has been 304 stainless steel. Occasionally, we're requested to do 316 stainless steel, which are all quite possible. However, we try to equip the internals or product contact primarily with stainless steel. There are occasions, as I mentioned in the presentation, where certain grades could be abrasive or they could be sticky. In cases like for abrasive applications, we have special grades of stainless and other wear-resistant materials. It could be tungsten carbide, it could be a spray coating, which would then obviously not be stainless steel. So for the most part, it's a mix of stainless steel and some wear-resistant, whether it's a tungsten carbide or a thermal spray coating.
Thank you. Next question. What is the expected life of a liner for an air classifier mill?
Well, it depends on the type of contaminant or grit that's in the carbon black. We've seen on average liners and hammers lasting 6 to 8 months. Most of the time longer. There are some more abrasive grades where perhaps changing every 4 months, but let's say on average every 6 to 8 months for most of the slightly abrasive grades.
Okay. What is the difference between an EACM and an EACM2?
Well, it's based upon the design of the internal components. We've modified internal components and the geometries to achieve a finer grade. More or less, without going into great detail about what those exact changes are, it's a different rotor assembly, different classifier assembly, it's a modified other internals, which would all contribute to making that distinction between the EACM and the EACM2.
Okay. How much material is lost or are separated in a separator system? I guess you're talking about the air classifier.
The Micron separator. Okay, so, excuse me. So what we've done is the Micron separator can be used to make different grades as well. What I mean by grades is I mean different particle sizes. So if you want to achieve, say, less than 5 ppm, we may be looking at a fines yield of, say, 95 to 98%. There are a lot of clients who want or can accept maybe that range, like I said. There may be cases where you want to have that near zero or zero grit. In cases like that, we may shoot for a lower yield, a lower fines yield of maybe 50 to 80% to achieve that really clean contaminant-free product, but then taking that coarse fraction and grinding or grit reducing with an EACM or EACM2.
Okay. Can a micro EACM2 reduce the grit on 500 mesh or other sizes?
Yeah, so I didn't focus on that 500 mesh sieve spec. Perhaps I should have done that, but what we're finding is, for the most part, we're measuring primarily with the 325 mesh, but we have from time to time measured on 500 mesh, and oftentimes we're below 5 ppm plus 500 mesh for a lot of these materials that I showed you here on this presentation.
Okay. Next question, what machine uses more power, the E2 ACM or the long gap mill?
It's a no-brainer. The EACM2 uses much less energy than the vertical long gap mill.
Okay. Next question. Do you have experience with recovered carbon black from waste tire pyrolysis processes?
Yes, we do. We have quite a bit of experience with this application. We've seen a shift over the past, say, 10 to 15 years where at the beginning it was mostly looking to achieve a top size of around 25 to 35 microns, in which case we'd use the ACM or EACM to reduce the particle size. But we don't look at that as a grit reduction. We look at that as a size reduction. So we're taking that crumb, which could be several millimeters in particle size, and reducing that down to a D97, for example, or D99 at 30 microns. There's been a shift in recent years down to finer and finer grades. So again, what I mean by grades is particle size. So what we've seen has been a shift to requesting a D99 or D97 of, say, 13, 15, 18 microns instead, in which case we're using a different technology. We're using our fluidized bed opposed jet mill, or AFG, to produce those particles. So it's a different milling technology, but yes, we do have quite a bit of experience with that.
Okay. All right, next question. Does the EACM require frequent part replacements like aligners and hammers, and how long does this maintenance take?
Well, the maintenance depends on the amount of time for maintenance depends on the size of the mill. So if it's a smaller mill like the EACM 10 or EACM 30, it would take a couple of hours at most. For the larger mills like the EACM 200s and bigger, you have that volute section which is bolted in, and you would need a hoist above to pick up that volute assembly to remove it and to get inside to the internal. So it would take a shift or perhaps even 2 shifts to make those changes. Mostly about a shift to make the changes.
Okay. Next question. What are your recommendations for carbon black from scrap tires?
Well, I think it kind of sounds similar to that question a couple of minutes ago, where we're looking at either, depending upon the particle size required for the recovered carbon black, it would either be the air classifying milling technology, like shown here, like the ACM or EACM2. But if it's for you're looking for a finer or smaller particle size, it would be our jet mill. It would be our AFG fluidized bed opposed jet mill.
Okay. Next question. How much material do I need to provide for a test on an EACM2 or the Micron Separator air classifier?
Well, based upon the anticipated throughputs that we foresee with the pilot size EACM number 10, we probably are looking for about a half a ton to a ton of material for trials.
Okay.
You can scroll down to look at the remaining.
Yeah, sorry. Just much from here. Next question. Air rates on the MS are fairly high. Is the MS Micron separator used mainly offline for the production unit?
Yeah, primarily it's used offline because the air volumes, yes, are very high compared to the EACM for grit reduction. So based upon that, taking up large pneumatics, that would most likely be an offline process.
Okay. Can you do an upgrade to an existing EACM to an EACM2 by changing the internals?
It's a little bit more complicated than that. The short answer is yes, but other modifications are required on the mill aside from the internals.
Okay. Can you elaborate on the jet mill's size reduction?
And I'll talk specifically for the recovered carbon black or the pyrolysis carbon black. What we're doing, what the goal would be to take we'll call it crumbs, the crumb size, which could be several hundred microns to say 3 or 4 millimeters, and milling it down to a median particle size, a D50 in a range of 5 to 7 microns, and a top size, so a D97, D99 in a range of 13 to 18 microns.
Okay. It appears that we've answered all the questions. If we've missed any questions, Bill and I will go through them at the end of the presentation and make sure we respond to offline. We'd like to thank you for joining us today. We hope that you enjoyed the presentation. We have recorded today's webinar and we'll be posting it to our website in the next 24 hours. We encourage you to come back and look at it again if you'd like, or share it with any colleagues. Bill, thank you so much today.
Thanks, Greg.